Welcome to second lesson, guys. Vijay from this side. In first lesson, we explored the types of machine learning model. Basically, we were exploring about supervised learning model, unsupervised learning, and semi-supervised learning. In this video, I will cover the types in semi-supervised learning model, and that is just starting of syllabus. I will cover complex topics as well, but before proceeding with the complex topic, my goal is to build a foundation which should be great enough to handle complicated topics in future videos. So for this video is going to help you understand are what is what are the different approaches in semi-supervised learning. It will be very excited and it will be very informative video. That is the main goal of this video. So let's dive into theoretical part. So in previous video we explored types of machine learning models. Uh, Specifically, we saw supervised, unsupervised, and reinforcement learning models. So we understood how they work and how they're different from each other. Now it's time to explore semi-supervised models. Basically, semi-supervised model is it is separated in several topics. You can say there are different approaches to handle semi-supervised data. Semi-supervised data in the sense the data which is labeled plus unlabeled data, the mixture of labeled and unlabeled data. So that also we covered in the previous video. So now I think it's time to dive into theoretical part. For this, I wrote one blog, one article. You can see that in my LinkedIn post as well. I will share that in the description. So this is the article which tells you about the types of machine learning model. Basically, most of the time when we are learning this machine learning, we forgot that there are several topics like self-learning, consistency regularization, generative models, graph-based learning. Most of the time we exclude these topics, right? We just know supervised, semi-supervised, offline versus online, then instance-based model or reinforcement learning we are trying to study. So the main goal of this video is to go beyond these four machine learning models or four machine learning techniques. We'll explore self-learning, consistency regularization, generative model, and graph-based learning. And you can also learn supervised and supervised learning model, the difference between them. Yeah, okay, I will. Yeah, okay. Semi-supervised learning. So basically, there are four types: self-learning, consistency regularization, generative models, graph-based learning. Let's see one by one. First, we'll take self-learning. So self-learning, what is the meaning of self-learning here? So basically, you just understand what is semi-supervised model. I already told you that in my previous video, but once again I will repeat that. Semi-supervised model will build on the data where you have combination of labeled plus unlabeled data, right? For this data set, you have to select semi-supervised learning approach to train our machine learning model. So here, this diagram tells you what is self-learning. You can see here label data, then model is there. So I will give you an idea how it works. Here is a model. You just give label data. You just paste label data from your entire data set and just left out the unlabeled data. Just take label data, feed then train your model with label data. It will get trained. Then you just after training, if give unlabeled data to same model, it will predict for this unlabeled data. It will create classes. It will create labels. Then add these labels to our entire data set. So that means we have whole data with labels now, and then you can train your model on entire data set. That is the approach in self-learning. Okay. Now let's understand. I forgot to use this here. Now let's see what is consistency regularization. So consistency regularization uses a data augmentation technique for training your model, and yeah, that is, I think that is the plus point in consistency regularization. Let me tell you what will happen when we use consistency regularization through same image. Okay, so we'll take label data as it is, then we implement data augmentation techniques. So data augmentation, that means creating or generating new data points based on previous or the existing data points. That is the idea behind data augmentation. So you are just increasing the data points here. Okay, you take label data, then apply data augmentation, then you will get more data. That is what it is. And then you just proceed, or you just feed that data to the model. Once you train model, then give unlabeled data to the model for prediction, then it will generate the labels. Then you add these labels into our data set and train your entire model from scratch. Okay, I think I should tell you that one drawing, it will be better to understand what is going to happen here. So we'll, what we are saying, we are looking for consistency regularization, right? Regularization. Okay, so this is a self-learning, sorry, not self-learning, semi-supervised learning, right? Semi-supervised learning model. Okay, so basically you have data with some labeled data which has labels, and some data with unlabeled data points. Okay, so now in consistency regularization, you just take this label data and give them to augmentation technique, or you can create augmented data by using label data. Augmentation, then it will create large data set, or you can say, you can, it will create new data points. Now you have two data sets, right? The first one, uh, this is the first, this is the first, and this is the second data set. Let's say this is your model. Now what machine learning engineer do, it will take this and this data set together, it will train this, he or she will train this model. That model will predict on unlabeled data, right? My drawing is not that much good, no worries. Okay, so this is unlabeled data, then it will predict for these unlabeled data. So prediction for unlabeled data. So now see, you have three data sets. The first one, that is labeled data, second one, that is the augmented data, and third one, which is the combination of unlabeled data plus labels predicted by this model. Okay, now you will take labeled data and the unlabeled data plus predicted labels, right? So now you have entire data set, that the shape of this data set should be same adds this data. Okay, so this is our training data. This should be our training data. So now this data is given to the untrained model or algorithm, you can say algorithm or model, which is untrained. So this is the new model we are going to create, right? So this is how consistency regularization works. So I think you can see there is a key difference in self-learning and consistency regularization, and that is data augmentation technique. So this technique is extra added in consistency regularization. Otherwise, both the techniques are same. So now let's understand what is the purpose of data augmentation. Right. Let's suppose you have let's suppose you have uh, 2000 labeled data points and 20,000 unlabeled data points. So if you train your model, if you go with the self-learning technique here, what you will do, you will take this data, you will train a model. After training, you will predict for these 20,000 classes with that trained model. Then you will add these predicted labels to this unlabeled data, and again you will train new model. Right? That is what you are going to do in self-learning. But there is a point. There might be an issue when you do this with the self-learning, because if you see here the labeled data and unlabeled data, it more unbalanced. What is the meaning of unbalanced data set? The unbalanced data set, that means if you see here labeled data points are only 2000, but unlabeled data points are large number. So there are 20,000 data points which are unlabeled. If you train that model with the 2000 data points, which is not sufficient in the machine learning, at least you should go with, I think, 20,000, 30,000 to create an ideal or create and fundamental or basic machine learning model. 2000 for data points are very less number. So if you do this with a self-learning model will not get trained, it will not figure out much more complex data. So that is why I think for next 20,000 data points, it will most probably it will be a wrong prediction. And if you proceed with this wrong prediction, probably you will lose the accuracy of the data. You may get accuracy on this trained data because you use these data points, right? But in when you use this model in real life, you will probably get very very disappointing feedbacks. So to avoid this, we are using data augmentation. Data augmentation techniques, I will explain some data augmentation techniques here. Let's understand it with one example. If you are dealing with image processing sorry if you are dealing with image classification model, then let's say you have cat images and you want to predict whether the animal showed in image is cat or not. That is what your target is, right? Let me draw a cat. So this is the cat. Okay, this is not the cat, but let's consider this is the cat. If you have 2000 data points with these kind of images, then you can generate more data by flipping this image or by rotating this image by some angle, 90-degree or 20-degree, 30-degree. So by blurring the image, by flipping it, by mirroring it. So there are several you can say techniques to generate another image by using this image. So if you can see here, I will do it. Okay, I got one image, right? So now if you see, the all two images are same, but if I rotated it a little bit, then it's not going to same. It's not The model will consider this image and this image is different because pixels are different. Pixels are in the different positions, right? So by using these techniques, you can generate more data. You can double down this number like 2000 uh, to the 4000 label data with augmentation technique, and then you can train your model. Then you can predict for unlabeled data points, and then predicted data points and unlabeled data will get combined together, and finally will train final or our last new model, which should be trained on labeled and unlabeled data. So that is the advantage in consistency regularization. Understood? Yes. Okay. Okay. Generative models. It's a very simple topic. Theoretically simple. I'm not saying that technically or code technically simple, but we'll see theoretical concepts only. So we can see here generative models. This is the same thing, but instead of data augmentation, we are using generative models to create a data points, right? So these models will create more new data based on new data points based on existing data. So this is similar to the data augmentation technique, and the rest of the techniques, the rest of the methods are same. So instead of this augmentation, we'll generate data by generative models. So this is called generative model based semi-supervised learning. Now this is the interesting topic, graph based learning. It's very interesting topic because it's very different from self learning and consistency regularization. So let's see what is happening here to this image. Yes, okay. So you have labeled images. Let's say you are dealing with images for now. There may be other data points, there may be other topic or other data that you are dealing with, but for simplicity let's consider for image. Our data point is image. So here for semi-supervised learning we have two types of data, labeled and unlabeled data, right? Labeled data and unlabeled data. Now if if you see here, we are creating clusters or image groups. You can see basically you are we are using unsupervised learning technique for our separation. Let me draw here. We have labeled data plus unlabeled data, right? So now the the main technique that is used is unsupervised model. Unsupervised model. So in previous examples we are using supervised model for prediction, but again this game is different. So first we'll give this labeled data and unlabeled data to this unsupervised model. Unsupervised model will create clusters, right? Suppose you suppose you are predicting for animal, you are predicting for cat, dog, and non animal like images, cat images, dog images, and non animal. I think non animal means it's going to be different from this dog and cat. Okay, so you will take this label data, unlabeled data, and it will clusterize this data into three clusters, right? Now in cat image cluster you will find some data from labeled data point, and some data from unlabeled data set, unlabeled data set, right? And same goes for dog and non-animal. Same goes to dog and non-animal. Okay, so now you can see here there are some data points with the label data. Here is also label data, and same goes here. This is label data, and this is the key thing that you are going to take a decision for each cluster. What is the meaning of that? So now if you see, if you explore this labeled data points from this cluster, which is predicted by this unsupervised model, if labeled data with majority classes for cat, if labeled data majority classes for cat, then you can say this particular cluster belongs to cat category or cat cluster. Okay, so same goes to this cluster and this cluster. So basically we are okay. There is a mistake I did. No, the model will not predict anything. uh, After this model output will be three classes only, right? So three classes, maybe anything, we don't know now, okay, uh, which class belongs to which category, right? Just assume that we have unsupervised model, then model created three clusters based on similarities in data. Now from each cluster take majority of labeled data point. If you found labeled data points, more labeled data points with cat category, then this cluster belongs to cat. Okay, if let's suppose this label the majority classes from majority from label data point data set is dog, then this cluster belongs to dog. And if same goes for the non-animals. Okay, so that is called graph based learning model. This is very simple technique actually, simple, and it's straightforward. And if you want to see a real life example of this graph based learning, you can explore Google Photos. Yes, Google Photos are using same technique. Basically, if you see, when you upload new photo on the Google Photo, then it will automatically take this photo and add this photo into similar kind of cluster, similar kind of groups. So this technique is going this technique the same technique that is called graph based learning is used in Google Photos as well. Okay, I think that are the types of semi-supervised these are the types of semi-supervised learning model. Okay, we saw self-learning, consistency regularization, generative models, and graph based learning. If you want to explore this article, I will share that in the description below. You can visit my LinkedIn profile as well and explore other techniques that we previously discussed, say supervised unsupervised model. And you can also explore offline versus online, instance based model KRI, then and model based learning. So these kind of techniques you can learn from this. I will share it into the description below. So yeah, that's all about semi supervised learning techniques. Thanks for giving your time, precious time. I hope this video is clearly explained, and if you understood the types of semi-supervised learning model in very basic words, you can say in very normal words, then comment down. And if you want if you see some if you want some improvement in my teaching process, then also you can comment down. I will try to improve myself as per the need. So that's all about this video. Thank you so much for joining.